Cemetero maths, stairs, rise, and run. Let's start off by defining some variables. This part that goes up will be the rise, and this part that the foot steps on will be the tread. Also, from the bottom of the first step to the top of the last step we'll call the height. From the beginning of the first step, the nose of the first step, to the nose of the last step we'll call the length. Okay? Also, we have here a number of steps. This is going to be important later on. Also, from the nose of each stairs has to line up perfectly like this. And the way to accomplish this is to make the tread and rise of every step the same. You can't have one step with a rise of 5 inches and another step with a rise of 6 inches and so on. Every rise and tread has to be the same for each step. Okay, now let's define some parameters. So the rise of each step has to be greater than or equal to 4 inches. So 4 inches is the minimum right here that we can have. And it cannot pass 7 inches. So the rise has to be between 4 and 7 inches. The tread, however, needs to be, I'm going to say, 11 inches. Really, it's supposed to be a foot, but each step here is going to have a little batter. And this little batter is going to be 3/4 of an inch. So we have 11 inches plus 3/4 of an inch equals approximately 1 foot, right? So the tread needs to be a foot total. Each tread needs to be a foot total at least. But with a 3/4 inch batter from nose to nose, we're going to use 11 inches in order for our calculations. Okay? I've heard that 12 is the minimum, but it can pass 12, and I've heard that it cannot pass 12 inches for the tread. So we'll just say the tread has to be 11 inches. Typically, we have a rise of 7 inches and a tread of 11 inches, but this includes a 3/4 inch batter. So 7, 11 is typical, but sometimes it doesn't always work out that way in real life because of existing structures like sidewalks or other things. And so sometimes we'll have to figure out what the rise and tread of the steps are, and here's how you do it. Our first equation will be the rise, and so the rise equals the height, GHT, the height over the number of steps, and the tread likewise will be the length divided by also the number of steps. Let's say we have a height of 4 feet and a length of 7 feet. Let's try that. So our rise would be our height, which is 4, and I'm going to say for this first example we'll say 7 steps. Let's try that. 4 over 7 gives us 0.57, approximately 0.57 feet, which is just under 7 inches, coming in at 6 7/8 of an inch. So although technically this does fit within the rise, it's very close to the 7-inch max. So we'll have to see how this plays out. With our tread, our length is 7 feet over 7 steps. That gives us a 1 foot tread. So with 7 steps, our rise is very close to the max of 7 inches, coming in at 6 7/8 of an inch, and our tread is a little bit big, is going to be a 1 foot and 3/4 of an inch, so a little bit big here. let's try. So let's try 8 steps. Let's see how that works out. So our rise of 4 feet over 8 steps gives us a rise of 0.5 feet, which is exactly 6 inches. So that checks out. That's good. We're better on the rise already. We're not so close as before. And our tread will be the length, which is 7 feet over 8 steps. 7 over 8 gives us 0.87 feet, which is approximately, let's see here, 0.875 is 0.75 is 9 inches plus 12, which is an inch and a half, we'll say is approximately 10.5 inches. So at 8 steps, our rise is good. It's at 6 inches, no problem. But our tread gets smaller, perhaps too small. We have a tread of 10.5 inches, which is actually 11. 10.5 plus 3/4 is 11.25 inch. So in this situation, again, I would take this to the superintendent. I would be like, hey, superintendent, we can do 7 steps with a rise of nearly 7 inches and a tread of over a foot, 3/4 over a foot, or we can go with 8 steps with a rise of 6 inches, no problem, but the tread is going to be a little bit short of that 1 foot typical. And maybe they'll want to do one or the other, or maybe they want it to be better and demo will be involved. Well, let's say we have a height of 6 feet and a length of say 10 feet. Let's do this. So our rise is the height, which is 6, and I'll say for this example, let's do 10 steps. 6 over 10 equals 0.6 feet, which is approximately equal to, oh, that's over 7 inches. That's like 7.25 inch, which is not going to work because that's more than our 7-inch max. So let's try this. Instead of 10 steps, let's try 11 steps. So our rise will be 6 feet over 11 steps, which is 0.54 feet, which is approximately 6.5 inches. So that's good. That checks out. 6.5 in between the 7 and 4. And our tread will be the length, which is 10 feet over 11 steps, which gives us 9.0. I'll just say this is, let's make this point round up, 0.91 feet, which is actually really close. This is equal to just under 11 inches, coming in at about 10 and 7/8 of an inch. So I'm going to say this is good. We're only off by 1/8 right here, but that's nothing. So with 10 steps it won't work, but 11 will work because we'll have a rise of approximately 6.5 inches, which is good, and a tread of barely under 11 inches, which is what we wanted, the ideal, at 10 and 7/8 of an inch. So we're good. So with the non-typical flight of stairs with a height of 6 and a length of 10, we would need 11 steps to get really close to what we need to complete this job. And this is how I calculate non-typical stair layouts for us cementeros.